poster is about global warming and the direct and indirect effects. We'll be talking into three different groups. One is the nitrogen cycle, one is thermohaline circulation, and one possible outcomes and something that's already happening. So for the thermohaline circulation is my domain. I'm going to first explain what the thermohaline circulation is. It is the only out of two sinks that we have for our atmospheric carbon dioxide. The other is biota, by photosynthesis. This is the process where the carbon dioxide, which is directly affecting our global warming and also the climate change, is dragged using this thermohaline circulation into the deep water, and then so that's kind of like extract all this atmospheric CO2 out of it. So the thermohaline circulation brings oxygen and like nutrient-rich substances from the deep water in the process of picking up dead carcasses and bring it up, and that makes the region that it comes up, which is upwelling, a very bioefficient region. And as you can see from this graph or this picture, this is a satellite image of the chlorophyll A, which is the substance that measures the photosynthesis. We can see that this region, which is the North Pacific, our local region, has a relatively high bioefficiency area. So this is directly influenced by global warming. If we have a higher level of global warming, then polar region will be less cold and then causing the water to be more fresh, and then less density will cause the thermohaline circulation to shut down. If this does shut down, as you can see from this graph, that the upwelling region of the North Pacific Northwest will no longer exist. That will cause a lot of problems, bring less nutrient water up to the surface for our species salmons, but also like impact our economy greatly because we're also very dependent on shellfish industry as well as fisheries. That is my part.
Right. So I'm going to be talking about ocean acidification and nitrogen pollution. Ocean acidification results from carbon dioxide bonding with water molecules and forming carbonic acid. And what this does in the marine ecosystems is it causes it to react with hydrogen instead of allowing allowing calcium to bond with carbonate ions for shellfish and other creatures. So essentially, ocean acidification is causing a lot of damage in marine ecosystems with crustaceans and other calcium compound organisms. Nitrogen pollution is seen when we dump large amounts of fertilizers or other nitrogen compounds into lands next to rivers or other outlets of water that either lead to lakes or oceans. And what that does is it causes potential dead zones, which are areas of low oxygen that cause marine life to die. Now, what is really interesting is if we combine both of these two things together, there seems to be some kind of reaction between carbon and nitrogen that mitigates the negative effects. What this could lead to is it could lead to stabilized pH in the ocean areas or lake areas that we're having these problems, stable chemical marine ecosystems. If we continue to deplete the marine life or the oxygen levels, essentially what we'd be looking at is marine life is going to die at a very fast rate. And if that happens, areas that depend on seafood for their main protein source, they're not going to do well. And then also our oxygen levels are going to deplete, considering algae does produce around 50% of the oxygen that we breathe every day. So by combining these two things, we'd be saving a lot of jobs and we'd be saving the economy in the area as well as helping mitigate the effects of global warming.
So one example to our global warming issues is the salmon fish. As people know, salmon fish have like a huge impact to our life, and it has been rapidly declining the salmon population due to the storm weather and the damaged habitat. And like storm water is basically the water from the snow and the river just rinses off everything from the land surface into the ocean. So you know, like all the waste was on the surface will end up in the same habitat or same environment with the salmonfish. And the acid in the water will kill the aquatic species. It's kind of related to this chemical nitrogen part pollution. And the salmon average weight back in years is like 90 pounds, and now it's shrinking into half sizes. So you can really see like the dramatic declining weight and the population of the fish. So we impose several partial solutions that can potentially solve the problem. One is produce less carbon expensive product and advertise green consumerism, which is corporate. We can will improve the environment together. It can't without anybody help. And address the carbon tax policy. That's mainly the government will contribute to this politics solution, and the fish letters and the green citizenship is always gonna be another way out. So this is our project. Thank you so much.